16 minutes before an explosion killed 15 workers, a control room display showed a level of 78%. But inside the tower, flammable liquid had climbed 158 feet, only 12 feet from the top of a 170-foot column. And it was still rising, two numbers, one impossible situation. How could a tower be on the verge of overflowing while the control room appeared to show something completely different? And if the danger was already this close, why did none of the refinery's safeguards prevent what happened next? At 1:20 p.m. and 4 seconds, the vapor cloud ignited. To understand why, investigators would have to rewind the disaster by more than 11 hours. Texas City, Texas. March 23, 2005. At 2:15 in the morning, a crew at one of America's largest refineries began bringing part of the plant back online after maintenance. At the center of the startup was a tall separation tower. Its job was simple to describe: heat a mixture, send the lighter part upward, and draw the heavier part away from the bottom. But a startup is not normal operation. Equipment is filling. Temperatures are changing, flow paths are being opened one by one. Until everything reaches balance, the amount of liquid inside can change quickly. If liquid leaves as quickly as it enters, the tower remains under control. But if it enters faster than it leaves, the tower becomes a hidden reservoir. The operators cannot see through its steel walls. They have to trust the instruments in the control room. And on this morning, the most important instrument was about to tell the wrong story. The level on the screen looked precise. It rose and fell 1 percentage point at a time. But precision is not the same as truth. The instrument was not measuring the full height of the tower. It was interpreting a small sensing range near the bottom. Worse, it had been set up using decades-old information from a time when the tower handled a different liquid. As the contents heated and changed, the displayed level could move downward even while liquid far above the sensor continued to rise. The screen could therefore show improvement while the real situation was becoming more dangerous. One misleading instrument should not be enough to create a catastrophe. Refineries are built with additional layers of protection, but the independent high-level alarm was not working correctly. The glass that could have provided a direct level check was too dirty to read, and a repair request involving the level instrument had been postponed until after the startup. 3 opportunities to challenge the screen. All 3 were gone. The crew did not yet know it, but they were entering the startup with no reliable view of what was happening inside the tower. At 3:09 a.m., one high-level alarm sounded. A second alarm should have confirmed that the liquid was still rising. It remained silent. The operator stopped filling when the display reached 99%. According to the screen, the tower contained less than 9 feet of liquid. Investigators later calculated that the real level was already more than 13 feet. It was the first clear gap between the picture in the control room and the reality inside the steel. Then the startup was paused for the next shift. The night lead operator left more than an hour before the scheduled end of his shift. The written handover said only that some liquid had been brought into the unit. It did not give the incoming crew a complete picture of how much equipment had already been filled. By sunrise, the tower contained more liquid than the new shift understood, and less protection than anyone realized. At 9:51 a.m., the startup resumed. More liquid entered the tower. Burners were lit to heat it. But for hours, very little heavy product left the bottom. The hidden inventory continued to grow. At 10:47, the experienced supervisor overseeing the startup had to leave because of a family emergency. No equally experienced replacement took his place. At 11:16, the display showed 93%. The real level was approximately 67 feet. At 11:50, the display had fallen to 88%. The real level had climbed to approximately 98 feet. The screen was moving down while the liquid was moving up. From the control room, the falling number could look like progress. The backup alarm remained silent. The dirty glass offered no contradiction. Every visible clue supported the same reassuring story. And every one of those clues was hiding the same danger. The question was no longer whether the tower was filling, it was whether anything could reveal the truth before it reached the top. At 12:41 p.m., pressure inside the tower had climbed sharply. The operators reacted. They reduced the heat, opened a vent, and tried to send more liquid out of the bottom. At 12:42, the display showed 80%. The real liquid level was about 140 feet. 38 minutes remained. At 12:59, product finally began leaving the tower. By 1:02, the flow going out matched the flow coming in. On paper, the tower should now stop filling, but matching the new flows did not remove the enormous amount already trapped inside. And the liquid was still heating and expanding. At 1:04 p.m., the control room display reached 78%. Inside, the level had reached 158 feet. Only 12 feet of empty space remained. 16 minutes to the explosion. As colder liquid higher in the tower warmed, it expanded and produced more vapor. The level continued toward the top, even with the outlet now open. No screen showed it. No alarm announced it. The final barrier was now the tower's emergency pressure system. But could that system contain what was coming? At approximately 1:14 p.m., liquid reached the top of the tower and entered piping that was meant to carry vapor. The rising pressure opened 3 emergency relief valves. The valves did what they were designed to do. They protected the tower from excessive pressure. But where would the released material go? Not to a closed flare system, where it could be contained and burned safely. It was sent to an older open-air collection drum connected to a 113-foot vent stack, a design dating from the 1950s. The drum filled, then the stack began to fill. The safety system had protected the tower, but it had moved the danger outside into an occupied refinery. 4 minutes and 22 seconds after the first relief flow began, flammable liquid erupted from the top of the stack. Witnesses saw a geyser rise roughly 20 feet above it. The liquid fell through pipes and steelwork, broke into droplets, and began turning into vapor near ground level. In just 107 seconds, approximately 7,600 gallons escaped. Now the disaster was no longer hidden inside the tower. It was spreading across the ground. The vapor cloud expanded through crowded equipment, parked vehicles, and temporary office trailers. Workers received a radio warning that the drum was overflowing. Operators moved to shut down the furnace and stop nearby traffic. There was not enough time to sound the site emergency alarm. Only about 25 feet from the release, a diesel pickup truck was idling. Witnesses heard its engine begin to race as the vapor reached it. Investigators later identified the truck as the most likely source of ignition. At 1:20 p.m. and 4 seconds, the cloud ignited. Flame accelerated through the tightly packed equipment. The pressure wave tore through the unit and destroyed nearby trailers. 15 contractors were killed, another 180 people were injured, 43,000 residents were told to shelter in place. But the explosion answered only what happened. Investigators still had to answer the harder question: why were so many opportunities to stop it already gone before the day even began? Texas City disaster changed refinery safety. Guidance was strengthened for the placement of temporary buildings, emergency release systems, process safety measurements, and worker fatigue. But new rules are only useful if weak signals are still treated as warnings. The lesson is not simply that one gauge was wrong. It is that catastrophes become possible when failed safeguards are accepted, unusual events become routine, and a reassuring number is allowed to replace an uncomfortable reality. At 1:04 p.m., the display said 78%. The tower was almost full. 16 minutes remained. This is industry unseen, the hidden systems that keep modern life running, and what happens when they fail.